In this video, we will find the relation between gravitational constant and gravitational acceleration. So, by Newton's law of gravitation, we have that force will be equal to m1 m2 over d square. That every two masses attract each other with a force F, which is directly proportional to the product of their masses and inversely proportional to square of distance between them. So after proportionality constant, we use G, where G is the gravitational constant. So in this lecture, we will find the relation between gravitational constant and gravitational acceleration G. For this purpose, this is Earth of mass capital M, and we assume that a small mass m lies on the surface of the Earth. So distance between this mass and center of the Earth is actually the radius of the Earth. Since the Newton gravitational law deals with the force which is directly proportional to the masses and inversely proportional to the square of distance between their centers. So the force between Earth and this mass will be equal to the product of this and distance between center of their centers, which will be actually the radius of the Earth. So I can write that F is equal to G, m1 let be the mass of Earth, which is capital M, and m be the small mass, over d will become radius of the Earth. Here F is the force of gravitation which act on the mass m, which will be equal to the weight of this body. So gravitational force act on the body of mass m will be mg, g m over r square. M and m will be cancelled on both sides, so the value of g become gm over r square. So this is the relation between gravitational acceleration and gravitational constant. So we can't find the gravitational acceleration at the surface of the Earth by this equation. If we put the mass of m, value of gravitational constant, and radius of Earth, we get the value of gravitational acceleration on the surface of Earth.